Saurabh is there? Saurabh?
Yes, ma'am. Shall we start?
Yes. Start, please.
Okay. A very good evening to all of you. Today, we all meet to be a part of a virtual journey through botanical world. It's virtual as we are now facing a tough situation, struggling in our daily lives to adjust ourselves to the new normal. As physical meetings or conferences are not possible with all the restrictions of the new normal, so we assemble online. But I love to mention that we assemble in really large numbers. Here, in this virtual journey, we will take you through the vivid world of botany, a subject that encompasses the scientific study of plants. But trust me, this journey through this scientific study through botany is actually a never-ending one. So, without wasting any more time, let's start traveling. Today, we have 3 sessions: the inaugural session, the technical session, and the interactive session, followed by a vote of thanks. To begin the inaugural session, I request the convener of the program, Dr. Remi Datta, head of the Department of Botany, THK Jain College, to address all of you with an introductory note about the program. Over to you, madam.
Thank you, Saurabh. Very good afternoon, everybody again. I, Dr. Rimi Dotto, on behalf of the Department of Botany, THK Jain College, would like to cordially welcome all of the participants, our respected Principal Madam, Coordinator and members of IQAC, and our honorable speakers on the first day of the online lecture series entitled Journey Through Botanical World, organized by the Department of Botany in association with IQAC of our college. Thank you for joining us on the first day of the session. We all are amidst an extraordinary situation emerging out of the global pandemic and the consequent lockdown. With this unprecedented lockdown, everything has come to an abrupt halt, and the academic world is not an exception. Because of the forced closure of educational institutions, the entire education system has been badly disturbed. In this situation, virtual pedagogy has emerged as the most effective option both for the students as well as the teachers. To fulfill our basic aim of development of academics, not only in our college, but also in different parts of the country and abroad, we have arranged this virtual lecture series for the benefit of the students as well as the teachers. Our eminent speakers will definitely enlighten the participants by enhancing their knowledge of the different aspects of plant life, including how did the members of the plant kingdom evolve, adapt themselves, their ecological character, their plant tissue culture, plant biotechnology in crop plants, etc. Our honorable speaker, Dr. Singh, will also guide us virtually to AGC Bose Indian Botanic Garden to see the botanically curious plants, including rare, endangered, and threatened taxa, as due to lockdown, no one has been able to visit the garden this year. I would also like to specially mention that we received a huge response not only from our country, from our state or our country, but also from different countries like Philippines, Egypt, Indonesia, Australia, Ethiopia, Malaysia, Thailand, Vietnam, Romania, Armenia, Oman, and our neighboring countries like Bhutan, China, Nepal, and Pakistan. We are overwhelmed by the response of the participants from such varied fields of profession and nationality, and would like to heartily thank them for their kind response. With this, I would like to request our respected Principal Madam, Dr. Moshumi Singh Sengupta, to officially introduce the lecture session.
Shall I
Not
start,
audible,
maybe?
madam. Not
Hello,
audible.
madam.
Shall I start?
Yes, yes, ma'am.
Okay. So, namaskar. Good afternoon, everyone. Warm welcome to all the participants of today's inaugural program of online lecture series, Virtual Journey Through Botanical World, which is organized jointly by Department of Botany and Internal Quality Assurance Cell of our college. We are very fortunate to receive Dr. Neera Sen Sarkar, Assistant Professor, Department of Botany, University of Kalyani, Dr. Basant Kumar Singh, Botanic Assistant, Botanical Survey of India, AJC Professor Ashim Kumar Ghosh, Retired Associate Professor of Botany, City College, Kolkata, and Dr. Gaurav Gangopadhyay, Professor, Division of Plant Biology, Bose Institute, as the speakers of this lecture session who have been the expert in their respective field. I offer my hearty welcome to all the speakers of various sessions of this virtual journey through botanical world session series. Now, thank you, madam. Thank you, Dr. Neera, madam, for accepting our invitation. Thank you, Dr. Singh and Professor Gangopadhyay for your presence, and thank you for Dr. Professor Ashim Kumar Ghosh for accepting our invitation to speak for a large number of audience. As I came to know from Dr. Datta's information that a large response we have received for this, particularly this online lectures, it is really, I mean, the very much proud and honor for us. Now, Department of Botany has been one of the important and I mean the oldest department of our college, which was established in the year 2006. At that time, it was basically it offered the general BSc general course at that time. But in the year 2017, I mean the academic session 2017-18 onwards, it has started offering honors course. I'm really proud to share with you the department has been very much active, not only in taking regular classes, lecture classroom organizing, I mean the taking regular classes, but apart from that, they are very active in organizing different various academic programs and also co-curricular activities for the students. I mean, always they want to keep their students busy in some kind of academic work. That is very good with about the department, and I am really proud that I mean today this department has come up with this kind of lecture session series. Now, as mentioned, as the organizers have already mentioned, really we are going through a severe crisis all over the world, and online education has been the only way to stay connected with this academic fraternity, not only with the students really, but also the teachers and all other, I mean the academic personalities. And today, and really we must greet this online platform that we are getting opportunity to hear from all of you, because otherwise it would have not been possible, because you are all of you are very busy with your regular activities and your regular academic schedule, but somehow you have found your valuable time for us, and we are able to reach a number of people all over the world. So thank you very much once again, Madam Nira and other speakers, and the all other speakers of this session. And thank you, organizers. Thank you, Dr. Rimi Datta, head of Department of Botany, other faculty members like Shaurabh, Anindita, and the IQAC coordinator, Dr. Dash, Shuchishmita Dash, and I mean the all the and obviously the faculty members of Computer Science Department for providing us this technical support for organizing this lecture series. So all the participants also, because you have got registered. I mean you will be a part of this academic endeavor taken by our college, and of course our the other non-teaching staff who are involved in any way with such a big task. So thank you once again, and thank you for listening.
Thank you, ma'am. It really feels great to start the program with such inspirational words. I would now request Dr. Shuchishmita Das, coordinator of the Internal Quality Assurance Cell of the college, to share a few words with us.
Am I audible, Saurabh?
Yes, ma'am, you are audible. Please continue.
So thank you, Dr. Bose. For the last 4.5 months, we have all shifted to this virtual world, which is now the new normal. Online classes, online lecture series, online workshops, everything is now online. And our college has been organizing several webinar and lecture series, and this particular event, A Virtual Journey Through Botanical World, is a very nice initiative that has been organized by Department of Botany in association with IQAC of Jain College. Very eminent academicians have given their consent to deliver the lectures. And my heartiest welcome to all our respected speakers, Dr. Neera Sarkar, Dr. Basant Kumar Singh, Dr. Ashwin Kumar Ghosh, and Dr. Gaurav Gangopadhyay. We're all looking forward to hear from you all, and teachers and students from different colleges from all over the world. I mean, it's really overwhelming that from all over the world they are participating in this event. A warm welcome to all of you, and thank you all for showing so much of interest to participate. Thank you, organizing team. They have been doing very hard work for the last few days. And with this, I wish all the very best to this event. And thank you. Thank you all.
Thank you, ma'am, for all the good wishes for us. Now we have come to the end of the inaugural session. So I would now request the convener, Dr. Datta, to begin with the technical session and introduce today's speaker, Dr. Neera Sarkar, to all of us. Over to you, madam.
Thank you, Saurabh. It is really a great pleasure for me to introduce Dr. Neera Sarkar, an assistant professor in the Department of Botany at the University of Kalyani. After graduating, she completed her post-graduation in Botany from the University of Delhi, subsequent to which she worked with an ICAR fellowship at the Central Inland Fisheries Research Institute and obtained her PhD degree from the University of Calcutta on the taxonomy and ecology of algae and their impact on fisheries in the Indian Sundarbans. She also holds a postgraduate diploma in intellectual property rights. She has about 24 years of research experience in the specific field of algae and mangrove biodiversity, conservation and ecology. Her areas of expertise include algae of the Sundarban mangroves, ecology, biodiversity, conservation and intellectual property rights. She has authored one book, Algal Flora of Sundarbans, Mongol, and co-authored a number of book chapters along with about 33 international and national journal publications. Is recipient of grants from the UGC DST, Government of India and Department of Environment, Government of West Bengal. She is also a recipient of the First Track Young Scientist Award from the Science and Engineering Research Board, Government of India, and has mentored a Rajat Jayanti Science Communication Fellow of the DST, Government of India. She has acted as the nominated algae expert of the Worldwide Fund for Nature Sundarban chapter and has been on panels of discussion on access and benefit sharing of bioresources. She has worked with the West Bengal Biodiversity Board, Department of Environment, Government of West Bengal, looking after documentation, conservation, intellectual property rights, and benefit sharing issues regarding biodiversity of West Bengal. She also has been a trainer of government officials of West Bengal in biodiversity conservation in a number of training programs on interactive coastal zone management (ICZM) sponsored by the World Bank. She has been an expert in the consultative workshop on alignment of National Action Program on the combating desertification organized by the Indian Council of Forestry Research and Education, Dehradun. She has provided consultancy services to different multinational companies in the fields of environmental impact assessment (EIA) and biodiesel production by algae. She is now actively involved with biodiversity conservation and related issues in her university and is the coordinator of the Biodiversity Working Group of Kalyani University and has taken initiatives to successfully establish a biodiversity park in the Kalyani University premises with special attention to butterflies, medicinal plants and arboretum. Please, Shoda, over to you. Shoda?
Yes, ma'am. Am I audible?
Yes.
Okay. So I cordially welcome Dr. Neera Sen Shorkar to begin with her lecture. A gentle reminder to the participants, do not unmute yourself or present anything during the course of the session. I repeat, do not present yourself during the course of the session. However, you can put up your questions in the interactive session in the chat box, both in Google Meet and YouTube Live. So let's learn about the arrival of the first greens. Over to you, madam.
Thank you so much, Dr. Bose. I would first of all like to thank the organizers of this series of lectures of the THK Jain College and the principal madam, Dr. Moushumi Singh Shengupta, and Dr. Rimi Datta, who initially talked to me about the whole thing, and I agreed to it also. I was very interested in speaking on this topic. I'm also thankful to Dr. Saurabh Bush and all the other organizers of this series, lecture series. And a very good afternoon to all the participants of this program. And I hope I live up to the expectation of the organizers and the participants of this lecture series. So before I start presenting, just give me a few moments, please. So here it is. My topic for today is the arrival of the first greens, and what I presumably will be doing during this session is discussing with all the participants of this webinar the circumstances under which the photosynthetic organisms came into existence on this earth since the time life started over here. So here we go through the arrival of the first greens. Now, Earth basically has many different planets, has been rather many different planets in its long history, and could be more. These are some imaginary views which were made by Professor Donald Brownlee. And the topmost, this one, is a water world. It's the expression of a water world before large-scale continents had formed. The next one, the whitish, this particular figure, is a snowball Earth. This is the phase with extreme glaciation and a world shrouded with smoke after maybe a large asteroid impact. These are all basically imaginary pictures, hypothetical pictures of the Earth that might have existed from time to time since the time it was formed and since the time life came upon it. This basically last one is of course Earth today with its life, the greens and the water, everything on it. So moving on, as I was talking about Professor Brownlee, just an introduction to him. This is a very interesting book by Professor Brownlee, and since we are in a situation where we have we could devote time to reading, exposing ourselves to many different aspects of our interests. So this might be a very good read also. This is a book by Professor Brownlee and Peter Ward, a geologist and an astronomer respectively, who have combined their knowledge of evolution of life on our planet and their understanding of the life cycles of stars and solar systems, and it talks about the life and death of the planet Earth. So before we go on to the arrival of the greens on the planet, it's more interesting to understand how the planet itself was born. So Professor Brownlee is basically a professor of astronomy at the University of Washington at Seattle and is the principal investigator for NASA's Stardust mission. His primary interests include astrobiology, comets, and cosmic dust. And this is a very what should I say, a very frightening expression of the Earth's future. And but definitely a very interesting read. So I would suggest to my participants that you could always go through this book when you are at leisure. So moving on, this is again a hypothetical figure, as you can understand. 4 billion years ago, or the time since when the Earth basically originated, that is around 4 billion years ago, things were definitely different. And this figure is, this diagrammatic representation is taken from NASA's Goddard Space Flight Center conceptually. Understanding of the environmental conditions on early Earth can be developed from 3 recent studies. They not only improve our understanding, but also help us to reconstruct the history of our own planet. And also kind of helps us in assessing the habitability of planetary bodies in general. So the first of these studies was taken up in the University of Rochester, and the reports are there in the Proceedings of the National Academy of Sciences, where the authors have presented evidence of a strong magnetic field around Earth from about 4.1 billion to 4 billion years ago. So that was the time when Earth basically was formed. And their conclusion is based on magnetite inclusions in certain minerals, and thus appears to be quite reliable. Though this is not my sphere of exact study, but it kind of corresponded with the talk that I was supposed to be giving. So I went through these literature, and I'm presenting whatever I could gather from these readings. And next we come to a very important question, is what was the Earth's atmosphere like at that time? So based on modeling works, it appears that it kind of consisted of at least 70% carbon dioxide. And people who are into such studies, and I presume there must be many participants who already have a background in such studies, leaving them out, the other participants might have, might develop interest in knowing what exactly was happening. So these particular slides or the explanations are basically for them. So it appears that, kind of this early Earth had at least 70% carbon dioxide. And we already know from previous research that early Earth atmosphere was very low in oxygen at that point of time. So this, it's likely that these high concentrations of this carbon dioxide concentrations, extended back to the beginning of Archean, about 4 million years ago, that life may have originated under this kind of an atmosphere. Another key environmental factor that was kind of affecting the early Earth was bombardment by meteorites. So that is what the figure also shows. And it was not just micrometeorites, but also large impacts, larger impacts rather. And we are, kind of faced with many such probabilities in recent times. But these things have probably happened in the past. And I have heard Professor Duari speaking on this topic. Basically, it's of quite interest. And what I have gathered from his lectures is that everything, every existence is by chance that is happening. So these bombardment by meteorites were much more common than today. Unfortunately, we don't have a complete record of these because, rocks older than about 4 billion years are very rare to find because they are erased by geological activities. So we can all, kind of create estimates or hypothesize what could have happened at that point of time. So moving on. Before we, start talking about the arrival of the greens, it is better to get an inkling to how the time period has been divided. So basically, the time period has been divided into many categories. The broadest category is the eons. And then we come to the eras, and then we come to the epochs or sub-eras. And finally, the smaller periods that we talk about. So, talking about eons, this particular slide shows that there were 4 major eons in the history of the Earth. The Hadean, which took up about 13% of the lifespan of the Earth. Am I audible? Hello, am I audible?
Yes, ma'am, you are clearly audible. Please continue.
Okay, fine. So the next eon that we know of is the Archean eon, which took up about 33% of the Earth's lifespan, and Proterozoic was followed the Archean, that took about more than all the other eons, that was 42%, and finally the Phanerozoic, that is just 12%, because we are still in it within the limits of the Phanerozoic eon. And all these 3 taken together, the Hadean, the Archean, the Proterozoic, basically comprises of this large era, which is the Precambrian, because the Cambrian period came in only with the Phanerozoic. So before that, it was all Precambrian, and that took up about 88% of the total lifespan of the Earth. The Phanerozoic has 3 important epochs within its consideration: the Paleozoic, the Mesozoic, and the Cenozoic, and which are again further categorized into epochs or sub-eras. We will be talking about these in detail, so I will not dwell upon them in this slide. Let's move on. So basically, this is the time scale, and this is how you could divide to get an understanding, because this time period is so large that it is beyond the comprehension of human understanding. So just to get an inkling of what billions and millions of years is, this is a diagram which kind of shows how the eons, the eras, the periods, and the epochs in geological time scale are divided. So eons are the largest ones, which took up about many billions of years. Then the eras, which are smaller, then the periods or the epochs, which came down to millions of years till the date we survive in, or we exist in the present times. So talking about the eons, they are the longest or the largest denominations of geological time. So we have 4 eons, as I told in the previous slide also. The Hadean, it is basically an informal division of the Precambrian time, and it occurred about 4.5 to about 3.8 billion. There are other things also which are said about this, and it is characterized by the Earth's initial formation from the the accretion of the dust, gases, and the frequent collisions of larger planet, larger bodies that used to come down, and again by the stabilization of its core and crust and the development of the atmosphere and oceans. So throughout part of the eons, impacts of extraterrestrial bodies or the celestial bodies, released enormous amounts of heat, and that likely prevented much of the rock from solidifying at the surface. But the conditions are very understandable by the name itself. The name is basically a Greek translation of the Hebrew word for hell. So that is how this time interval is referred to as, and of course there was no life on Earth at that point of time. And if we talk about it in terms of the Earth's lifespan, it took up about 700 million years. So the next eon that we refer to or we designate as is the Archean eon. It is the earlier of the 2 formal divisions of the Precambrian times, and it dates back to about 4 billion years ago, and the lifespan or the time span of this eon was about 1500 million years. And this was the period when life first formed on Earth. It began about 4 billion years ago with the formation of the Earth's crust, and extended to the start of the Proterozoic eon. That was about 2.5 billion years ago. And the Archean eon is basically characterized by the records, the initial formation wherein we get the records of Earth's primitive atmosphere, oceans, etc. And the fossil evidence of these earliest primitive life forms in the form of prokaryotic microbes from the domain of archaea and bacteria appear in the rocks from about 3.5 to 3.7 billion years ago. So this is how, and there are many, important mineral deposits also that we could talk about, and mainly gold and silver also came along at this point of time. There are granite belts, greenstone belts, etc. Moving on to the next eon, which is probably till now the largest one, which is the Proterozoic eon. It is the younger of the all the Precambrian times, because this is the last of the Precambrian time, and it spanned from about it's nearly 2000 million years, and it dates back to 2.5 billion years ago, and it lasted till about 541 million years. So we have moved on from billion to million years ago. So we are coming closer to our present times that way. So basically the eon, this Proterozoic eon, is often again divided into Paleoproterozoic, Mesoproterozoic, and Neoproterozoic, meaning that the older Proterozoic, that is the Paleo, the Meso, the middle Proterozoic, and the Neoproterozoic means the newest one. So the Proterozoic rocks have been identified on all the continents, and the ones who know about why it is found in all the continents, and I'm sure there are others who don't know why it's spread over all the continents. I'll be making this point clear in my subsequent slides. And during this eon, the atmosphere and oceans changed significantly. And the rocks contain many definite traces of primitive life forms and the fossil remains of bacteria, blue-green algae, and the first oxygen-dependent animals, the Ediacara fauna. So that, makes this eon a very important eon in terms of life, starting to thrive on this earth. Lastly, the last eon that we are going to discuss is the Phanerozoic eon. It had a span of till date of about 570 million years, and it started from since the time Proterozoic ended of that's 541 million years until the present times. It represents only the last 1/8 of the time period that the Earth's crust has been in existence. But its importance, of course, is exceeds much more than its relatively short duration. So this is the eon where visible life could be found, and this particular period is again divided into 3 major spans. Now these 3 major spans are basically called as eras, which we will again discuss in my subsequent slides: the Paleozoic, the Mesozoic, and the Cenozoic eras. And although life, clearly originated at some point of this particular era, probably life particularly originated in Archean, as we talked about it in the last slide also. But there was a rapid expansion and evolution of these forms only in this particular eon, and they could, kind of fill up all the various ecological niches that were available to them. So the key to this great Phanerozoic expansion appears to lie in the development of plants, which were able to carry out photosynthetic processes and release free oxygen into the atmosphere. So this is where all the importance of this discussion comes in. And we all know that before that time, the Earth's atmosphere only contained very negligible amount of free oxygen, and the energy transfers, the processes of respiration and all the energy transfer processes were very critical and unable to develop because of the lack of oxygen. So during the Phanerozoic, Earth gradually assumed its present configuration in terms of letting life thrive, in terms of its present configuration, in terms of physical features of geographical origin. Basically, the processes like continental drift, mountain building, continental glaciation, all of these processes and phenomena, started and ended during this period. So that, kind of justifies the way we say that this is the most important eon that we look forward to. The next classification, which is only limited to the Proterozoic, the Phanerozoic, and which, this basically it is divided into the eras, and this is the next largest interval into which the geological time period is divided. And this encompasses all the major time intervals and is defined on the based on the life forms, on the fossil life forms which were found in the rock layers. So we have the Hadean, the Archean, the Proterozoic. None of them had any recognized eras. So there are 3 geological eras which are currently identified: the Paleozoic, the Mesozoic, and the Cenozoic. And each of the names of the eras reflects basically the relative stage of development of life. So Paleozoic means old life, Mesozoic is middle life, and Cenozoic is new life. The Paleozoic era is the oldest of the 3 eras, and it kind of dates back to about 544 or 540 to 250 around million years ago. And during this era, multicellular living things acquired hard body parts, bones, vertebral columns, etc. So next, the middle life forms are the Mesozoic era. We have it kind of extended from about 250 or 248 million to about 65 million years ago. And it was important for the fossil remains of dinosaurs and other reptiles that lived or thrived during this period. But this landscape was occupied also by many other life forms like the insects, the early mammals, the conifers, the ferns, and also finally the flowering plants and birds. The last era, Cenozoic, it began about 65 million years ago, and it continues to present times, and it marks the extinction of the dinosaurs. And the Mesozoic era basically marks the extinction of the dinosaurs, and Cenozoic era never saw the face of the dinosaurs, and vast new habitats and environments were created for early mammals and birds to adapt and to occupy every nick and corner of the earth. Now these are the eras and epochs, again confined to the Paleozoic, Mesozoic and the Cenozoic time periods. And we will be talking about all of these in detail when I talk about the arrival of the greens, which will specifically be the algal arrival of the algae on the face of this earth, different groups of algae. So I'll be discussing them in detail at that point of time whenever each of the slide comes in. Now, this is a composite timeline of the arrival of the earliest greens, the algae, which will be my focus of presentation today. So, starting from the Archean again, this is the oldest geological evidence of early life is found in the Archean, and the cyanobacterial fossils and stromatolites are found in this period. Then we move on to the early and the mid Proterozoic, and this Proterozoic era, the early and mid Proterozoic era, I have divided or separated it out from the late Proterozoic era because of the differences in the appearance of algal flora in these three different periods. So during the early and mid Proterozoic era, we find the earliest geological evidence of eukaryotes, abundance of stromatolites, which are the fossil records of the cyanobacteria, and early multicellular red algae and photosynthetic straminopiles appeared during this period. So that is important in terms of the early and mid Proterozoic. Talking about the late Proterozoic era, the stromatolites kind of decreased, and what appeared during this period were the early multicellular green algae, and all of this is based on the available fossil records. Now next we move on to the Paleozoic, which which witnessed the diversification of green algae and the appearance of coccolithophores. All of them are important algal groups, as we all, being students of botany, know. Moving on to the Mesozoic, we saw the diversification of green algae once again, the appearance of dinoflagellates, diatoms, and the coralline red algae. Finally, the Cenozoic, which is the newest time period that we can talk about, and herein we find a decrease in dinoflagellates, the evidence of brown algal fossil records, and the last one, diversification of diatoms, being the most important one in the understanding. And this diatoms basically appeared mostly in the Jurassic. The earliest diatoms basically appeared in the Jurassic, which is the Mesozoic time period, and since then they have served to be very important indicators of the understanding of the Earth's crust because of the way that they are preserved in the Earth's crust, and we get fossil records in terms of the diatoms, the dinoflagellates, and the coccolithophores. Again, the oldest geological evidence of early life, as I was telling, that it was in the early Archean that we find such evidence. And in terms of the cyanobacterial fossils and stromatolites, these are all the pictures of stromatolites that I could. Hello. That I could. Hello. Hello. There's some disturbance in the sound, I presume. Hello. Hello.
Dr. Sanmuga, sir, can you please mute your microphone?
Okay.
Thanks.
And
Everybody, please mute your microphone.
okay, thank you so much, Dr. Bose and Dr. Datta. And moving on to the mid-late Archean, again we find abundant stromatolites and geochemical evidence of cyanobacteria and the early Proterozoic, as I was talking about in the last slide also, that possible early photosynthetic eukaryotes appeared, and the cyanobacteria possibly colonized land also during this time. So this is the kind of records that the fossil evidence give us in terms of the arrival of the first greening organisms on the face of this earth. Next, we move on to the the Precambrian period, moving on from the Archean, and there's a wonderful paper by Nicholas Butterfield, which talks about the Proterozoic photosynthesis, a critical review. And these are the figures that I have taken from his particular paper, and I'll be telling you what these are. Sorry. All of them are basically the cyanobacteria, but this last figure is only of the red algae. As I told you that this was the time period during which, apart from the cyanobacteria, apart from the stromatolite evidence, we also get the evidence of the arrival of the red algae, the earliest red algal flora, and of a certain few photosynthetic straminophiles. So the first figure basically over here is of the cyanobacterium Eantophysalis belcherina, and this was found in Canada, the Hudson Bay, and this is a continuous pistulous mat. The second figure is basically the localized pistules of the cells, which shows multiple extracellular envelopes, and the C is basically the type specimen of this particular species. These are localized colonies of this particular cyanobacteria that I'm telling, and all these figures are attributed to the Geological Survey of Canada. And the second figure is the putative subsection 2 of fossil cyanobacteria, and this is Polybecerus bipartitus, which is a stalked unicellular cyanobacterial fossil, which can be broadly comparable to a modern biocide forming marine cyanobacteria. And the second one is of course a type specimen of Hyala campbelli. Hyala is a extant species, and this particular species is a fossil form which is known as the Eohyala, and it is an endolithic colony with pseudofilaments broadly comparable to those of the extant Hylacean cyanobacteria, the ones that I was talking about just now. And this is from North China basically. Eohyla rectoclada, which is again a type specimen, again an endolithic colony with pseudofilaments which are closely comparable to those of the extant Hylacean cyanobacteria. Hyala is a very impressive kind of a cyanobacteria, since it's very easy to identify once we get it in our specimens, the extant form of course. And this is from early middle Neoproterozoic limestone dolomite series in East Greenland. The next subsection 3 is basically the silicified halithrix from Canada again. This is Siphonophycus, and all of these are, falsely branching Siphonophycus group of algae. All of them belong to the cyanobacterial group, and this, of course, is the helically coiled filamentous microfossils, which can be compared to the extant Spirulina arthrospira, except for the presence of a robust extracellular sheath, which is present in this particular species. And this one is the Proterozoic eukaryote that I was talking about, the first eukaryotic species, or the first eukaryotic green to be coming into the onto the land. Green in terms of being the presence of chlorophylls in this, though it's a red algae. This is the Bangiomorpha pubescens, which we all read about, and this is a Bangesian rhodophyte from the late Mesoproterozoic formation of the Arctic Canada. Then you have Proterocladus. This is again a probable Siphonocladidian chlorophyte from the early middle Neoproterozoic, and this is Peliastrum dictocrinum. Again, this is a probable Hydrodictasian chlorophyte from the early middle Neoproterozoic. So these are the earliest evidence of photosynthetic organism, photosynthetic eukaryotes specifically, which we can talk about. And the photosynthetic straminopile that I was talking about is basically where the scientists tell us about its Polynella specifically. So the photosynthetic straminopile is basically Polynella species that we talk about. Now we will talk about the algal evolutionary events in detail in the Paleozoic era. So the Paleozoic era is divided into these periods, starting from Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian. We are all familiar with all of these terms, but just a quick, going through what is happening. This Cambrian period actually witnessed the abundance of Dasycladalian green algae. Ordovician, the Permian. Basically, I'll be talking about from here. The Cambrian period saw the outburst of acritarchs, and it is known as the Cambrian explosion. Next, we come to the Ordovician. I'll be talking about Cambrian explosion also. Ordovician period saw the abundance of marine green algae. The Silurian period provides evidence of early calcified reproductive structures of the Karelian green algae. The next, Devonian, is known for its earliest known fossil desmids. The Carboniferous, with its Mississippian and the Pennsylvanian periods, saw the appearance of Coccolithophorids and freshwater Botryococcus, and the Permian basically saw the abundance of Dasycladalian green algae. So this is the Cambrian explosion that I was talking about, and this basically marks an important point, very important point in the history of life on Earth. It is this time when most of the major groups of animals first appeared in the fossil records. And this event is sometimes called as the Cambrian explosion because of the relatively short time in which this diversity of forms appeared, this large, this immense diversity of life forms appeared. And it was once thought that the Cambrian rocks contain the first and oldest fossil animals, but we already know that this is, this can be attributable to the earlier Ediacaran strata also, because that is where the first animal groups came into existence. So this understanding has improved over the years from this being considered as the first period in which the animals came in, to the understanding that no, it was the Ediacaran formations where we find the first animal-like, animal-like structures or organisms which were present on the face of this earth. So the Cambrian explosion is the explosion of life in which only a very few simple organisms that existed just before this period suddenly burst into an immense variety of more complex organisms. Basically, this period, this Cambrian period, was sandwiched between two ice ages, and the sudden environmental changes are at times held responsible for this explosion. Now, again, moving on from this understanding, we also kind of say that this explosion may have had other impacts also. So the end of Cambrian period is marked by the mass extinction of about, we have already moved on to the next period, which is the Ordovician, and the end of the Cambrian period was marked by a mass extinction, which was about 490 million years ago. And this kind of ushered in the next epoch, which is the Ordovician, and it was marked by a mild climate because, as I told, that there was two ice ages, and then there was a mass extinction, and then a mild climatic epoch until the end of this Ordovician. And Africa glaciated, shallow continental seas were seen over North America, and here is the first time where we see the arrival of bryophytes also. So another group of greens also come in at this point of time. So Hepatocopsidas fossils are abundant during this Ordovician, and it is kind of understood that the bryophytes or the hepatocopsid bryophytes arrived and became abundant during the Ordovician period. Among the algae, Ordovician has evidence of abundant marine algae. So we have Winnipegia, Manitobia, Kinwoya, all of them are probable red algae that were found in the Ordovician, and I have also given the source from where I have taken these figures. We move on to the next epoch, which is the Silurian, and the earth kind of underwent considerable changes, and these changes had important repercussions for the environment and on the life that was there, on kind of thriving on the earth at that point of time. And one of these results was the melting of large glacial formations. Now this melting obviously led or contributed to substantial rise in the levels of major seas, and this period, this epoch, witnessed a relative stabilization of Earth's general climate, and the henceforth seen erratic climatic fluctuations kind of came to an end at this point of time. And coral reefs made their first appearance during this period. The earliest fossil of vascular plants were found in the Silurian, and among the algae, the most important evolutionary event that can be talked about is the presence or the finding of calcified remains of Karelian reproductive structures. So these are the figures from the Silurian, the fossil figures from Silurian. Next we move on to the Devonian. Significant changes again took in the world's geography this time during this Devonian epoch, and the world's land kind of collected into two supercontinents, the Gondwana and the Euramerica. A major collision was set in motion because of this coming together, and finally in the Permian, this coming together resulted in the formation of Pangaea, which is the single world continent that we all know about. So this, this coming together started during the Devonian period and ended in Pangaea in the Permian. So near the end of Devonian, again a mass extinction event occurred. So this, was the glaciation and the lowering of global sea level is thought to have triggered this kind of a crisis. And why is it thought so? Because all the evidence point towards that warm water marine species were the most affected because of this mass extinction. And talking about algal evolution or the evolutionary significant events in terms of algae, the earliest known desmid fossils appeared at this point of time. So the greens, unicellular greens appeared in the form of desmids during this epoch. We move on to the Carboniferous. The term Carboniferous is separated, we all know, into the Mississippian, which is the early Carboniferous, and the Pennsylvanian, which is the late Carboniferous subsistence. Now, this division, why was it established? So, distinguish between coal-bearing layers of the Pennsylvanian from the limestone Mississippian. So, the Pennsylvanian are the coal-bearing layers and the Mississippian are the limestone-bearing layers. And, this kind of resulted in different stratigraphy in different continents. And what happened was, again, if you, just remember the picture that the two continents, the large mega continents are coming together till date. They have not yet joined into Pangea as of this period that we are talking about. And the beginning of this Carboniferous had, uniform, tropical, humid climate, which kind of exists today also. But seasons, if any, existed at that point of time were indistinct. It was not so distinctly understood in the fossil forms that how this Carboniferous, had seasons at that point of time. Carbon dioxide content lowered and oxygen was at its historic high. So oxygen was very high. The climate was uniform. It was tropical. Humidity was there, and all these were indicators of life thriving in a better way, in the most expansive way during the Carboniferous. And we are all aware of this understanding that Carboniferous led to the formation of huge amount of, biomass in terms of plant material, in terms of organic material. Talking about the algae, it was the coccolithophores which appeared during this period. These are the coccolithophores. This is from the Lyell's collection of, and the next important assimilation or addition to the incoming of greens is the arrival of the freshwater green algal genus Botryococcus. Botryococcus is a very important genus because it has plenty of oil, 80% oil in it, and all the subsequent oil-forming deposits were basically because of such groups of or genera of algae which are known for their oil contents. We move on to the Permian, and this is the last period of the Paleozoic era. And the distinction between the Paleozoic and Mesozoic is made at the end of the Permian because of, again, another large mass extinction. In fact, it was the largest mass extinction recorded in the history of life on Earth. It affected many groups of organisms in many different environments, but the most affected community was the marine community. And it, kind of caused the extinction of most of the marine invertebrates of that time. So by the beginning of the Permian, the motion of the tectonic movements had already, kind of brought the two lands that were coming, trying to come together to fuse in a supercontinent, which we know as the Pangea. And what happened to the rest of the Earth's surface? It was occupied by a corresponding single ocean, which was known as the Panthalassa, and a smaller sea, which was to the east of this large, huge land mass, which is of Pangea, which is known as the Tethys Sea. And the Permian ended in the largest mass extinction that the Earth has ever known, the great dying that we all talk about. And if we talk about algal evolutionary events, the Dasycladian algae were becoming abundant during this period of time. So the Dasycladian algae were dominating the earth in terms of the algal flora during the Permian. We move on to the next timeline, which is the Mesozoic. And the Mesozoic, of course, is divided into three important epochs, the Triassic, the Jurassic, and the Cretaceous. So the Mesozoic era has three epochs beginning with the Triassic, and the ancestors of the major plant and animal groups that exist even today first appeared during the Mesozoic. But this era is, best known for its, the dinosaurs, and it's called as the time of the dinosaurs. And the Paleozoic, basically, as I was talking about in the last slide also, and the Paleozoic ended, and Mesozoic again started with a huge extinction event, which is called as the Great Dying. And this is basically this particular extinction event was much more severe than the extinction event that wiped out the dinosaurs. So the Triassic was the first period of the Mesozoic, and both the dinosaurs and mammals evolved during the Triassic. The Triassic ended and the Jurassic began with another extinction event, which was again less severe than the event that divides the Paleozoic and the Mesozoic. And during Jurassic, the dinosaurs dominated the large terrestrial niches, birds evolved flight, and the real age of dinosaur began during the Jurassic. Jurassic is also the time when if we talk about the algal evolutionary events, it is also the time when the dinoflagellates underwent major radiations, the coccolithophores became abundant, coralline red algae appeared, and early diatoms also appeared during this time. I'll be discussing all of this in detail when I talk about Jurassic. The Cretaceous was the final period, and again it resulted, or the end saw another massive extinction. So we move on to the algal evolutionary events in the Triassic. We discussed this in detail. The Triassic period was conventionally considered as one of the warmest period of the Earth's history. So we had a hot house world during that time. The poles were ice-free even during the winter months. Limited climatic variability was seen all over the Earth. But the past, detailed study in the past 2 decades, stratigraphic data, significant refinements to the geological timescales have revealed a considerable level of complexity and variability of Triassic climates as well. So conventionally, what was thought to have limited climatic variability is now known to have had a considerable level of complexity and variability in terms of climates. So the Triassic began with the largest mass extinction in the Earth history and ended in a series of substantial extinctions. So it ended in the largest mass extinction of the Earth the Earth has ever known. So among the algal events, the dasyclidalians became abundant, the dinoflagellates appeared, as I was already telling you about them. And this is from Witkowski's Marine Microfossils, which is a very, very important publication by Andrews Witkowski. And these are the dinoflagellates of those times, fossil forms, of course. So we move on to the Jurassic, which is very, a kind of lovable event, a period, because of the dinosaurs. Maybe even those who are not acquainted with, understanding or anything about this whole change of the Earth's face in terms of arrival and departures of organisms are well aware of this particular term, Jurassic. Maybe because of the movie that goes with the same name, the Jurassic Park. The Jurassic was basically a time of significant global change in continental configurations, oceanographic patterns, and biological systems. And during this period, the landmass that had come together to form the supercontinent Pangaea started splitting apart. So during the early Jurassic, animals and plants and living, both on the land and in the seas, recovered from one of the largest mass extinction in Earth history. So, that was very trying times for all of the animals and plants. And the Triassic-Jurassic boundary is marked by one of the 5 largest mass extinctions, where about half marine invertebrates went extinct. When we talk about algal evolutionary events, the dinoflagellates underwent major radiations. There was a lot of diversification. The coralline red algae appeared, and the first diatoms appeared during the period, during the epoch Jurassic. Next, we move on to the Cretaceous of the Mesozoic era. The Cretaceous is the longest period of the Phanerozoic eon, and it kind of spans about 79 million years. It represents more time than has elapsed since the extinction of the dinosaurs. So the total period is more than the time since when the dinosaurs disappeared from this earth. So you can imagine the time span that the Cretaceous was there on this earth for. So it was marked by high sea levels. There was cooling in the beginning and warming in the end. Flowering plants or the angiosperms arose close to the beginning of the Cretaceous and became abundant as period progressed. And though dinosaurs were the most dominant animals of this period, many modern animals, including the placental mammals, made their debut. They arrived on this earth during this period of Cretaceous. And you have a many algal evolutionary events of importance that were made during this epoch. What were they? The chrysophyte stomatocysts are seen. The fossil remains of chrysophyte stomatocysts are seen from this Cretaceous. Coccolithophorids peaked in their density as well as diversity. The silicoflagellates appeared. The calcareous dasycladalian became abundant. The marine diatoms appeared. There was an important radiation in Charophycine algae, including origin of the modern lineages, and the fossil forms of freshwater green algae, Pediastrum and Synodesmus, made their appearance. So there was a lot of things that were happening in terms of algal evolutionary events. So we have kind of reached the end of the Mesozoic also, and we'll move on to the Cenozoic era. The Cenozoic is basically divided into 3 main periods and a series and a number of epochs within those periods. So what are the periods? We have Paleogene, we have Neogene, and the Quaternary. The Cenozoic era actually began about 66 million years ago, and it extends to the present times. It is the time interval during which the continents assumed their modern configuration, at the way we see them at present, the way we see them placed on the earth in present time. So the geographical positions were decided during the Cenozoic era. That finally stayed till date. We know that it's a very dynamic process, and there may be movements, there may be tectonics which may change their appearance, but the present day appearance is supposed to have started from the Cenozoic era. And the flora and fauna evolved towards those of the present time. So the flora and fauna that we see in present times is also attributable to those that originated or kind of could live in the Cenozoic era also. So the first one was the Paleogene, the first period that we can talk about, or the epoch that we can talk about, is the Paleogene, which was the first period consisting of 3 epochs: the Paleocene, the Eocene, and the Oligocene. And after the 5th mass extinction came, just after the KPG or the KTA, whichever we call it, and suddenly there was a complete absence of dinosaurs. That was very, surprising, because the dinosaurs were completely, removed from the face of this earth. The ferns became abundant during this period. Climate warmed, and extensive tectonic activities are noted. Next was the Neogene period. It consists of two epochs, the Miocene and the Pliocene. The temperature became moderate, glaciation in southern hemisphere, the significant evolutionary events also happened. And finally, the Quaternary, which is absolutely the recent times, which consists of two epochs, the Pleistocene and the Holocene, or the recent that we live in present days. It is the age of the humans, and the most major algal evolutionary event that can be spoken about or discussed during this time is the major diatom radiation, along with what we have been doing to them. So invasions by non-native algae resulting from human activities in particular is the major evolutionary or major significant event which will have evolutionary fallouts in the Cenozoic era. So we talk about the Paleogene period, which is made up of the three epochs, the Oligocene, the Eocene and the Paleocene. So it marks the beginning of the Cenozoic. It began 65 million years ago and lasted more than 40 million years. And it was, in the beginning, it was warm and moist compared to today's climate. And much of the earth was tropical, subtropical. And by the end of this period, the climate began to cool. There were major geographical events and they were very interesting during this period. So during the Oligocene, we see that Australia separates from Antarctica. India crashes into Asia, creating the Himalayan mountains. Antarctica gets covered by glaciers and the sea levels are low. The next epoch is the Eocene, wherein the North America and Europe separate out. And finally, the Paleocene, wherein the North America and Europe get joined together. Australia is joined with Antarctica, and India is not connected, not yet connected with Asia, and they kind of have started separating out. And what are the algal evolutionary events? So talking about the coming of the greens, what happened during this period is that this Paleogene includes Paleocene, Eocene and Oligocene. The Paleocene spanning from 65 to 54 million years ago, the freshwater pinnate diatoms appeared. So the first diatoms appeared in the Jurassic, followed by the marine diatoms, and then in the Paleocene we get the first freshwater pinnate diatoms. 80% of the coccolithophores go extinct, but they leave their imprints within the sea to tell us the story of previous years. So that is why these groups are very important in terms of understanding the story of the earth. So algae becomes, or basically certain algal groups have gained a lot of importance in this, understanding of this history of the earth or the story of the earth that I've been talking about all this time. And dinoflagellate diversity increased. Next, we come to the Eocene, which spanned from about 54 million years to 38 million years ago. The freshwater, I have already talked about this. The freshwater green algae involved in the formation of oil deposits increases, and basically we could say it was Botryococcus and other genera which have these oil deposits within them. The next is the Oligocene, which is about 38 to 24 million years ago. The coccolithophores declined and then again they increased. The Dasycladalian algae declined and diatom diversity increased. Again, I have a series of diatoms, fossil diatom pictures from the Paleogene sediments of Western North Atlantic, which was used in understanding diatom biostratigraphy by again Andrew Witkowski. He's a very renowned diatomologist who works on such sediments and interprets chronology of the earth using diatom subfossils, fossils also. Then the algal evolutionary events of the Neogene, which includes Miocene and Pliocene. So the Neogene period encompasses the interval between 23 million years ago and 2.6 million years ago, and it includes the Miocene and the Pliocene epochs. So the Neogene, which means newborn, was designated as such to emphasize that the marine and terrestrial fossils found in the strata of this time. What were the climatic events? The temperature remained moderate during this period, and among the algal evolutionary events, we find a peak in silicoflagellate diversity, and the evidence of fossil brown algae appears. The kelps started dominating the ocean floors from this time period. And these are the beautiful silicoflagellates, which is again a very recent paper of 2019 of silicoflagellates of the Black Seas. And this kind of gives an impression of the seasonality, distribution from the sedimentary records. And this is part of the deep sea research of the tropical studies in oceanography. Algal evolutionary events in the present times, that is in the Quaternary, including the Pleistocene and Holocene. So Quaternary is one of the best studied parts of the geological records, and it is divided into two epochs, the Pleistocene and the Holocene, which is the present times. The Quaternary rocks and sediments being the most recently laid geologic strata, and it can be found at or near the surface of the earth, in valleys, in plains, in seashores, on sea floors, and they have been studied worldwide in abundance. People, the most studied rocks are probably the Quaternary rocks, because they're easily available, and not only because of the easy availability, because they're found everywhere. It's easier to start working on the Quaternary rocks. The most distinctive changes seen during the Quaternary were the advances of ice into the temperate latitudes of the Northern Hemisphere. And since the early 1970s, a major tool for understanding changes in global ice volumes, temperature, sea level, have been the records of these stable isotopes of oxygen, which were extracted from marine fossils, cave limestones, and ice cores. And the algal groups which serve as important component of such studies are, of course, the diatoms, the dinoflagellates, the silicoflagellates. And the major, I've also repeated this earlier, the major algal evolutionary events during the Quaternary includes the multiple invasion by non-native species resulting from human activities, which was never seen before, and the major driver of all climate change events, or the major driver of subsequent sixth extinction, if we could talk about that, and the next major evolutionary event is the major diatom radiations that have happened in this epoch. And you have beautiful diatom structures from diatom research, which is this particularly is from the Thalassiocera structures from the Pleistocene sediments, all fossil records from Japan. It's a very important study, and coming to why this interests me so much is because my team is also involved in limited studies on the diatom assemblages of sediment cores of the deltaic islands of Indian Sundarbans and finding out the paleoecological significance. And I have a very beautiful team which is always with me in this study, and I have my students, Dr. Manjushree Mondol, Dr. Shanuat Sheikh, Dr. Bishwajit বিশ্বাস, Srijani Chaudhary, Abhravit Chaudhary, Devopriya Bashuli, Amit Haldar as a group. The first three have completed their PhD, and Manjushree Mondol has basically worked on the diatom assemblages of the sediment cores, and we collaborate with Professor Joanna Wigzorek of the Łódź University of Poland. And this is basically, I'll just give you an overview of our work and the place where we work and the methodology that we follow to understand the origin or the story of diatoms arrival and the change that they have brought about, to understand or to interpret or to reconstruct the strata of a place with which we are so familiar in West Bengal, which is the Sundarbans. And it's not only in India or in the West Bengal, it is a worldwide important area, in the Sundarbans, which is unique in many ways, in terms of its mangroves, in terms of its flora, fauna, etc. Not going into those details, I'll just give you a small, understanding of what we do. We use a manual corer from different sites, which could be in the forest area, and it could be in the human habitation or also area. And these are the diatoms. We actually got about we have till date identified about 172 species of diatoms from the sediment cores, and only 8 of them match with the extant species. The rest of them are very different from the extant species. So these are the diatom species from the different sediment cores of the 2 sites that I'm showing over here. We are already working on 2 more sites from different locales of Sundarbans, Indian Sundarbans. So these are all from the strata, the sediment core strata that we have, extracted and identified using light microscope, using scanning electron microscope studies. And I won't not go into the details, but this is how we interpret the sediment soil characteristic. And finally, we go for carbon dating, which has been done at Botany Institute and also at IUAC New Delhi. And the 4 carbon dating results kind of reveal the calibrated ages. These are the kind of ages that we have got from one place. This is the kind of result, and from the other spot, these are the calibrated ages that we got. So we have got sediment as old as 7,342 years before present from one site. And of course, the diatom flora of those periods also. So the standard protocol for extraction of diatoms from these saline sediment samples of estuaries has been established in our lab. And total number of diatom species documented is not about the from the core, it is including the extant and the ones reported from the sediment cores. And the taxonomy based on these have been done, the statistical analysis has been done, the carbon dating has been done, and these are the unique diatoms that we got, and which kind of reflect upon the characteristic of those dates that we found by using carbon dating, etc. And we could interpret and reconstruct the total course using these studies. I'll just quickly go through this, and that is all that I have to say for this session. Thank you for giving me a patient hearing in this regard. And
thank you, madam.
yeah, thank you.
Yeah, so it was really a very enlightening lecture with such explicit and detailed presentation. So I seek your permission, madam, to move on to the interactive session, because there are a lot many questions in our both Google Meet platform and our YouTube Live platform. So if you can please answer them for us.
Yeah, sure.
Okay. So I request my colleagues and members of the organizing committee, Dr. Anindita Singh Roy and Dr. Orpita Mukherjee, to begin and with the interactive session and coordinate the same. Thank you.
Thank you so much, Shoro. I hope I'm audible. Am I audible?
Yes, you are.
Yes.
First of all, thank you so much, ma'am, for your very vivid and very thought-provoking presentation. If you can see, there have been loads of questions in the chat box. So due to time constraint, maybe I'll not be able to take all of them, for which I apologize. But I wish to take as many as I can. Okay, ma'am. So with your permission, I'm taking up the first question.
Yes.
And the first question is, could we expect that new life is still evolving as that in the ancient times? Do you think there is an organism which scientific world is unaware of and having more advanced features than human being apart from the animals? Share your thoughts. Well, the similar question has been asked by a number of our participants in different languages, but the question is more or less similar, that is life still evolving, and Yes, ma'am. Please.
I'll definitely take this question. It's a very interesting and thought-provoking question, rather. But the only thing is that it's a very hypothetical question. Life is evolving. There is no doubt about it. It's a very dynamic process. But something that is evolving more than a human being is a hypothesis which I presumably will not be able to answer at this point of time. And but definitely life is evolving, newer forms are regularly being formed, and if we look into the number of organisms being added to the new list of understanding, and we all know as biology students that we at this point of time just know about 80% of most of the microbial world. Sorry, 80% remains unknown. It is only 20% that we know till date. So either they have not been identified, not been described, not been found, and also the ones that are getting added day by day. All of them, keep on adding to our not understanding of how much biological life is there, or biotic organisms are there on this earth. But answering a question which kind of amounts to whether they will be more evolved than human is a very is a thing that kind of pertains to science fiction. So I don't think I'll be able to answer that.
Okay. Thank you, ma'am. Ma'am, a question on similar note that I'm just taking up half of it because the other half you have already answered. That is there any advanced human being, or I think he meant to say that advanced human form on any other planet than Earth, or any second version of human being, such a question like that?
No idea.
So I don't think,
I'm sorry.
Yes. Any fossil record is available for microorganisms like viruses?
Viruses?
Yes, ma'am. Is there any fossil record for microorganisms like viruses?
I don't know. I'm not sure.
Okay. Ma'am, one more question. Why diatoms didn't change too much during the course of evolution?
No,
Is it their cell structure that helped in this regard?
No, this is a very wrong question, in fact, Dr. Mukherjee. Diatoms have evolved, and this present time, as I was telling in my last slide also, before I started my own, explaining what I have been doing, the last slide was also saying that the most recent times have seen the most important ecological or evolutionary change in terms of diatom radiation. So there has been a lot of diversification of diatoms since the time they evolved or they came into existence since the Jurassic, and there has been a lot of change and lot of evolution, and diatoms are probably the next most important organisms after the insects. We all know that insects are the most varied form on the face of this earth, and if we talk about the same in plant life, diatoms come first that way. The ones that have not evolved are the cyanobacteria. Since the time they were formed in the early Archean times, since then there has not been much evolution, and that can be attributable to the absence of sexual means of reproduction in the cyanobacteria. But diatoms have definitely evolved a lot. We have many new forms.
Okay, thank you, ma'am. Another question is there. When maximum diversity laws took place in which era? Maximum diversity laws in which era?
That is probably the extinction of the which era?
Yes,
okay, it is
that is the question. Somebody has written that is which era there is a maximum diversity laws.
Just a minute. It will probably be the Permian.
Permian.
Yeah.
Okay, thank you, ma'am.
Because that was more massive than the dinosaur loss.
Sure. One more question, ma'am. Whether DNA of fossil algae is possible to separate, how is it significant in the study of evolution? Should I repeat?
No, I have got your question, but this is, something like, since I myself work on datum fossils or subfossils, because when I'm working on Sundarbans, I cannot claim them to be fossils, but they're just subfossils. But the only problem is that with our kind of setup, it's not possible to extract DNA. It's theoretically possible, and maybe things are being done, but with the kind of amount of material that we get, and then the understanding of the same, and then going for extraction, maybe in a mass form they will be coming, but not separately. You cannot separate them out. I mean, it's not possible with our kind of setting. But it's definitely being done, because it's theoretically said everywhere that it can be possibly done.
Ma'am, another question. Any sixth extinction to happen in near future? You have talked about 5 extinctions.
Yes,
So
of
any
course, the sixth extinction is happening. In one of my previous presentations at a different place, I had talked about this. Sixth extinction is as true as climate change. We are already in the midst of the sixth extinction.
Okay, ma'am. Thank you, ma'am. That will be all. Now I'll request my colleague, Dr. Anindita Shinghoroy, to take up questions from the YouTube platform. Over to you, Anindita.
Thank you, Orpita. Am I audible?
Yes, of course.
Yes, you are. Please.
Thank you, Orpita. Am I audible?
Yes, Anindita, you
Okay.
are.
Firstly, I would like to thank. Firstly, I would like to thank you, ma'am, for such an informative session. So, ma'am, some of the questions that I am going to ask from the participants. Firstly, I'll begin with the question: which is the oldest algae discovered, and in which period?
The cyanobacteria in the archaea.
Okay, ma'am. And related question: which is the oldest algal representative found in Indian subcontinent?
Again, it will be cyanobacteria.
Okay, ma'am. Thank you. Ma'am, next question related this is: where from does algae originate by evolution?
I couldn't get this question. What is it?
Where from does algae originate by evolution?
The question is not clear, but still I'll take it. Maybe the question could have been reframed in how algae, evolved maybe. So the starting point, if we take as the origin of the cyanobacteria, then the subsequent things that happened after that, which led to the evolution of more algal forms, is obviously the endosymbiotic theory. The serial endosymbiosis that happened as a series of events that keep on happening, and it's still evident that it happens, is what has led to the evolution of so many different forms of algae, and of course the plastids also.
Okay, thank you, ma'am. The next question: what are the current challenges about diatom diversity?
The major important challenge of identification, if that is what the question is meant to be asked.
Participant might have asked for.
Is that basically we all rely, in the tropical countries, we all rely on temperate literature, because most of the datum identification, taxonomic work has been done in the temperate regions. It's very less in our areas, and what we do is basically depend upon those literature in trying to identify the forms that we get in this part of the world, wherein we meet with the problem of not matching in toto all of the characters that the temperate forms have been described to be. This is one. And the second most important challenge is the presence of cryptic species. The third most important challenge in terms of datum identification is the this half done literature of explaining the forms or describing the forms.
Okay, ma'am.
These are the three main
Thank you.
challenges. Yes. Thank you so much, Anandita.
Ma'am, some few more questions if you could please answer.
Yes, sure.
How did coccolithophores started to increase after they had declined?
How did they increase? You know, it's very
How they have started to increase after they had declined?
in evolution, this how is a very difficult question to answer. It's basically the data.
Yes, ma'am.
It's fact-finding data that we give in terms of these results. That this is what has happened. Like giving explanations of how the dinosaurs appeared is difficult. Rather than their disappearance is more, probable answers can be got about that. But the the
Yes.
way they come into the existence is difficult to explain, I presume.
Okay, ma'am. Another question regarding algae. Was there any complete destruction of algae occurring during the past?
No, the first ones to have appeared are obviously the cyanobacteria, and the cyanobacteria have never been wiped off. And the forms that have come on the later dates, maybe if you could talk about Glaucophyta, which wiped out to a large extent, and we are still with the ones which appeared long time back, but we still don't have many forms existing on the face of this earth. Maybe they couldn't survive, but they totally wiped off is the total algal group wiped off at any point of time has not been done.
Okay, ma'am. Another question, please. What are the most dangerous threats to plant diversity extinction at present? Might be the participant was trying to relate the past with the present.
Threat, of course, the ones that we identify for biodiversity loss remains all of them. Climate change, of course, then the breaking down of habitats, then pollution, of course, sea level rise, all these anthropogenic pressures. These are the main causes of destruction or threats that we pose towards any kind of biodiversity, not only plant diversity. Overconsumption. These are the ones, the 5 major threats that we consider towards biodiversity.
Okay, ma'am. Another question. How can we assure the preservation of these early green as of today? May I repeat, ma'am?
No, I got your question. Preservation.
Okay, ma'am. Yes, ma'am. How can we assure the preservation? Yes, ma'am. Will I repeat once more?
No, I got your question. How can we preserve the early greens? We can't preserve early greens. The ones which are gone are gone. The ones that are present is, of course, through awareness, through our responsible actions. What else?
Yes, ma'am. And one very direct question. What is stromatolite?
Stromatolites are the fossil forms of the cyanobacteria.
Might be it would be asked by any student who is new to this topic.
Yes, sure. That is why I do.
Okay, ma'am.
I had said this in the beginning also, the stromatolites.
Thank you, ma'am.
Yeah, sure, Anindita. Thank you so much.
Yes, ma'am. Thank you, ma'am. I hope this was the last question of today's session, and already have thanked ma'am. Thank you, ma'am, again for answering all the questions so patiently and being so kind. Now I would request my colleague and member of organizing committee, Dr. Saurabh Bose, to offer the vote of thanks. Over to you, Saurabh.
Thank you. Before going for the vote of thanks, I just received a small message in the Google Meet. I would place it to you, ma'am. It's preservation or conservation. Only this much was written.
That is why I asked what the question is about preservation. It's basically conservation that the questionnaire must have been asking about, because preservation is not is not the way it has been asked. It is basically conservation that the person must be asking about. And I repeated the question. That's why. Was it preservation that you were asking about?
That's one. No, just what. Why I repeated is was because preservation and conservation are so related terms, but they mean so different.
Yeah,
So
they have a very different meaning, and that is why I asked Anindita that is it preservation that somebody is talking about, or is it conservation? Yes.
Okay. So thank you, ma'am. I'll move on to the last part with the vote of thanks.
Yeah, sure.
So it's not only a privilege, but an honor to express my gratitude while proposing the vote of thanks to all dignitaries, participants, and others associated with the program. Firstly, on behalf of the Department of Botany and myself, I extend a heartfelt vote of thanks to all the speakers for accepting our invitation and be a part of the event. Thank you all. The entire organizing committee is extremely thankful to Dr. Neera Sharkar to grace today's session as the chief invited speaker. We are really honored to have her amongst us. Thank you, madam, for your wonderful lecture on the arrival of the first greens with such vivid presentation. Your time and effort is greatly acknowledged and highly appreciated. Thank you, madam. I must mention our deep sense of gratitude for our respected principal madam, Dr. Mahashumi Singh Sengupta, also the chairperson of the event, for being with us not only throughout today's session, but thoroughly from the days of planning and initiation of the event. She has been a constant support and a pillar of motivation and encouragement for us. I also extend my thanks to IQAC coordinator, Dr. Shuchishmita Das, and all other members of IQAC for their enormous cooperation in organizing the event. I'd like to place on record our hearty thanks to the members of the college authority and the members of the governing body to provide us with all the facilities to make the event successful, and of course to give us the opportunity to organize the event. I must acknowledge the expertise and efforts of the computer science department in handling the technical matters to set up the webinar. My sincere thanks to Mrs. Rituparna Kundu, head of the Department of Computer Science, for her contributions. I express my deep gratitude for Mr. Shomotonu Odhikari for his help and assistance in setting up the YouTube platform, without which accommodating all the participants would really have been a challenging job to do. The soul of any event are the participants. So thank you all students, scholars, faculty members, and each and every one of you for turning up with so much zeal and enthusiasm and in such large numbers from all parts of India and abroad. Without your active participation, the event will not have been so graceful. Before winding up, I thank all my colleagues, our beloved HOD Madam Dr. Rimi Datta, who have worked day and night for this event. So thank you all. With this, we come to the end of the session. I request all participants to note the link for attendance form for day 1 given in the chat box of Google Meet and YouTube Live. Please note it and fill up the form correctly before submitting. The forms will be active and will remain active tomorrow till 4 p.m. That is 13th of August till 4 p.m. Some of you have not received your serial number. For them, I say, if you have not received your serial number, do not fill up anything in the serial number. Do not fill up anything in the serial number for those who have not received the serial number. Just fill up the rest of the form and submit it. Put your name and your email ID correctly. Thank you. See you all tomorrow. Stay home, stay healthy, and be on time for tomorrow's session. Thank you all. I hereby end today's session. Thank you.